Welcome back to my YouTube channel. Today we are still on the uses of dimensions. Today we talk about the first use of dimension is used to find the unit of a physical quantity. Now the second use of dimension is that dimensions are used to check the validity of an equation. Dimensions are used to check the validity of an equation. So dimensions are used to check whether that equation is what valid. Or so if the equation is valid, it means that we have that equation in the system. Yes. If it's not valid, it means that equation does not exist in the system as well. So it is used to check the validity of what of an equation. Sometimes you meet a lot of what formulas or a lot of what equations. Yes. So if you see some equation around, you can use dimension to check whether that equation is valid or it exists. How am I getting it? Yes. So it is used to check the validity of that equation. It is used to check the validity of that equation. So you're able to notice that this equation exists in the system. Okay. Now, first example, that's example one. They check the validity of the equation. Check the validity of the equation. That's v squared equal to u squared plus 2ax. Yes. So that is the equation. That is the equation. So we are supposed to check the validity of it. Yes. Whether that equation is proper equation. Yes. So we are explaining the terms. Where v, the v here is the final velocity. Yes, final velocity. And u here is the initial velocity. So we have the initial is talking about where it started, and the final is where it was ended. I hope I getting it. A car will start from somewhere and it will end as well somewhere. So where the car will start, we call it initial velocity, and where it will end is called the final velocity. So u here is the initial velocity, v is the final velocity. Okay. Now a is acceleration. A is what is the acceleration, and the s is the distance. S is the distance. So we are supposed to use dimension to check the validity of this equation. And for you to know that this equation valid, it means when you find a dimension at the left hand side, the equation at the left hand side, it should be the same thing like finding the dimension at the left hand side. So the left hand side should be the same like the dimensions at the right hand side. So now we are coming to we are going to use dimension to check the validity of this equation. Thank you. Okay, so now we take the dimension of the whole of the terms. We take the dimension of the terms. So this the velocity, the final velocity. We take dimension of it. V equal to, then you take the dimension of the u as well. U it is squared plus 2 acceleration x. So you take the dimensions of the terms. You take the dimensions of the what? Of the terms. What's the dimension for velocity? Velocity is LT neg 1. LT neg 1. Yes. But it is squared, right? It is squared. Equal to. Yes. So equal to, this is the initial velocity. Initial velocity. So LT neg 1 as well. That one to so a square. That one to a square. Okay. Plus 2 multiplying acceleration. So what's the dimension for acceleration? It's what? LT neg 2. LT neg 2 multiplying distance. And what's the dimension for distance? It's what? L. L. Okay, so now we have this one. L2 T neg 2 because you are expanding the bracket. So under L2 T neg 2 plus 2L. When this one multiply this equation, it's what? L to the power 2. Yes, because L times L to the power 2. T to the what? Power -2. Right? Yes. So we have L2 T -2 equal to, so you can see the question here, you have 2L to the power 2 T to the power -2. What is here is the same thing what is here, but here 1 is here, but you don't write it. So 1 plus 2 it gives us 3L to the power 2 T to the power 2 as well. Yes, T to the power 2 as well. Yes. So we have L to the power 2 T to the power 2 equal to 3 L to the power 2 T to the power 2. So you can see that the equation at the left hand side is the same as the equation at the right hand side. Yes. This one we don't consider the constant. Yes. We don't consider the constant. We consider the dimensions. Yes. So even if you handle the same, you don't consider that one. Okay. So we can see that the equation at the left hand side is the same as the equation at the what? Right hand side. Okay, so you conclude. Since the equation at the left hand side is the same as the equation at the right hand side, then the equation is valid. Yeah, so you can see that we're able to what we got it at the left hand side, the same as what we got at the right hand side. They are the same. Yes, they are the same. They are the same. This is constant, so we ignore it. We can start with ignore them. Yes, so we ignore them. So since the equation at the left hand side is the same as the equation at the right hand side, then that equation valid. Yes, the equation is valid. The equation is valid. So this equation is valid. So as I said first, we take the dimension of all of them, all the terms. So we take the dimension of the V, take the dimension of the U, take the dimension of the A, take the dimension of the S. V is the what? Velocity, final one, velocity. So it's, if you take the dimension of it, it's what? LT in 1. But it is squared, so square it. Equal to U is the initial velocity. So that one too, the dimension of it is what? LT then 1 as well, but it's square, you square it. Then plus 2, the dimension for acceleration is what? LT then 2 multiplying the dimension of distance. Distance is L. Okay, you expand the bracket, so it goes L2 T multiplying this one become what? T -2 equal to, you expand it L2 T -2 plus 2 L2, because this one multiply this one become what? You have 2 L2 then T to the power -2. Yes. So one is in front of this one, but you don't write it. You can say this one is same as this one. So this is 2. This one is in front of it, but just that we don't write it. So it's got 1 plus 2, 3. So 3L to the power 2 T to the power -2. And what is at the left hand side is what? L to the power 2 T -2. The constant, we ignore it. Yes, so you can see that what is at the left hand side is the same as what is at the right hand side. So then you conclude, since the equation at the left hand side is the same as the equation at the right hand side, then the equation is what? Is valid. Thank you. Okay, so example 2. It says check the validity of the equation. Check the validity of the equation. So we have F equal to mg plus v. F equal to mg plus v. Okay, so F is the force, M is the mass, and G so is the acceleration due to gravity. G is the acceleration due to gravity. Okay, so we are checking the validity of this equation. So this is the equation. So after that, we take the dimension of the thing. Take the dimension of the thing. so this is the equation. So after that, we take the dimension of all the terms. So we have taken the dimension of the F, we have taken the dimension of the mass, we have taken the dimension of the G, we have taken the dimension of the V. Okay, now what's the dimension for the F? F is the what? Force. So dimension for the force is N LT 2. You know it already. Dimension for the M is mass. That's M. Then multiplying G and taking the dimension of G. G is acceleration due to gravity. So dimension for acceleration is LT net 2 plus dimension for V. Now, know that the dimension for V is velocity. So LT net 1. LT net 1. So you can see that what is here and what is here, they are all different. Right? You have MLT net 2 here, MLT net 2 plus LT net 1. Because they are, this is the equation at the right hand side, this is the equation at the left hand side. So this equation cannot even add them because they are different. They are different. So concerning this one, the equation at the left hand side is different from the equation what at the right hand side. So we conclude that since the equation at the left hand side is not the same like as that of the equation at the right hand side, then the equation is not what valid. So since the equation at the left hand side is not the same as the equation at the right hand side, then the equation is not valid. Yes, then the equation is not valid. It's not valid because we have MLT neg 2 here, we have MLT neg 2 plus LT neg 1. So the equation at the right hand side, this is the equation at the right hand side, this is the equation at the left hand side. You can see that they are different. Yes, what is here is not the same as what is here. Then, so since the equation at the left hand side is not the same as the equation at the right hand side, then the equation is not valid. Okay, so example 3 says that show that the equation t equal to 2 pi root of hp over g is dimension correct, where t is the period, h is the length, p the density, and g the acceleration due to gravity. Yes, dimensional correct also means that the equation is not valid. It means the equation at the left hand side supposed to be at the equation at the right hand side. If the equation at the left hand side is the same as the equation at the right hand side, then that the equation is what dimensionally what correct as well. Okay. So now this is what we have. T equal to 2 pi over t equal to 2 pi, then root of hp over g. Yes, this is what we have. Okay. So we take the dimension of all of them. We take dimension of all of them. Okay, so take dimension of t. 2 pi is constant. So then take the dimension of the h. We take the dimension of the p. We take the dimension of the g as well, right? So the terms, we take the dimensions of the what? Of the terms. We take the dimension of the terms. We take the dimension. Let me write it over. Yes, so you take the dimension of all the terms. So you have taken the dimension of the t, you have taken the dimension of the h, which is the length, you have taken the dimension of the p, which is the density, and you have taken the dimension of the g. Okay. So we are continuing at the side. So you get t equal to 2 pi t is equal to 2 pi. Then, yes, so because the dimension for t is what the period is what t. Yes, the period, the dimension for period is what is t. Okay, so equal to 2 pi. Then root of dimension for h. That's the h is the what? H is the length, so it's L. Is L. Multiplying P. Dimension for P is what? P is the what? Is the density, right? You know the density is what? Mass over volume. So if we're taking the dimension for density mass over volume, so m over L to the power 3. So it's what? Density for volume is m L to the power negative what? 3. Yes. M to the power negative what? 3. Okay. All over the dimension of acceleration due to gravity. Dimension for acceleration due to gravity is what? LT neg 2. LT neg 2. Okay, so continue. T is equal to 2 pi equal to this one, the top one you get m L because this plus 1. So, and this negative 3. So if you add them, plus 1 plus negative 3, it will give you what? Negative 2. Yes, okay. All over LT neg 2. LT neg 2. So now T is equal to 2 pi equal to root of, yes. So you get M. You have negative 2 here. Whilst this one it has positive 1. Whilst it will become negative 1 as well. So to join this one, so the L you get negative 3. Negative 3. Yes. Negative 3. Okay. Then whilst the t is also moving up, it's negative 2 here. Whilst it's moving up, you into negative. So we again like a pop. So you get t to the power 2. Yes. To the power 2. T to the power 2. Okay. So you continue. So you want to remove the bracket, right? You want to remove the bracket. So you square both sides. You square both sides. So you square the t, then 2. Is you have square both sides. You have to square both sides of the equation. You have square both sides. Let me keep it. So you get t square equal to 4. This one, the 2. If you square, you get 4. Then you square the pi, you get 4. You get pi square. Then the square here will remove this bracket. So you get m L negative to the power negative 3 t to the power negative 2. Yes. So this is the final answer. So you can see the equation at the left hand side is not the same like the equation at the right hand side. So now you conclude since the equation at the left hand side is not the same as the equation at the right hand side, then the equation is the equation is not valid. Then okay, yeah. So since the equation at the left hand side is not the same as the equation at the right hand side, then the equation is not valid. What is here is different from what is at the left hand side. Thank you for enjoying the scan use of what I mentioned. Thank you.